looking at lesson 3.2, complex numbers. So it starts off with this question: what is the square root of -4? Well, to get the square root of something is a number that you multiply by itself to get that perfect square. So, looking at a simpler problem, right? What is the square root of 9? Right? Well, I know 3 times 3 makes 9. So I can say that the square root of 9 is 3 squared. I also know that -3 times -3 is equal to 9. Right? So I know that this, so looking at lesson 3.2, complex numbers. Before we delve into that, let's look at the concept of square root. So if I asked you, what is the square root of 9? Well, square root is asking us that what number times itself, or what number squared, is equal to 9. Right? So I know that 3 times 3 is 9. Right? So a square root of 9 is 3. However, I also know that -3 times -3, right, would also give me 9, because negative times negative is going to give me that positive. Right? So the square root of 9 is plus or minus 3. So then if I asked you what is the square root of 4, right, you could use that same concept. Well, I know that 2 times 2 is 4. So -2 times -2 is also 4, right? So the square root of 4 is plus or minus 2. But let's get into this concept of complex numbers. What is the square root of -4? And this is a concept that mathematicians started thinking about very early on. Back in the 1 and 200s, mathematicians were looking at this and pondering, okay, what do I do with a negative value that I want to take the square root of, right? Because looking at this, what is the square root of 4, -4? Well, I know that 2 times 2 gives me 4, and -2 times -2 gives me 4. But what is the only way I can multiply and get to -4? Well, I know that I would have to have one positive and one negative, right? So 4 times -4 would give me, or 2 times -2 would give me that -4. But that is not a square root, right? Because how do I write this as something squared equals -4? We get kind of stuck in a loop because there is no real number solution to this, right? Because to get a negative number, by multiplying two numbers together, one of them must be positive and one of them must be negative. However, there are numbers called imaginary numbers that allow us to solve this type of problem. Okay, so the key concept here is the imaginary unit is defined by this equation. The square root of -1 is equal to I, which stands for the imaginary unit. Okay, so therefore I squared is equal to -1. So what this is going to allow me to do is divide out the negative from this square root, right? So back to the square root of -4. what is the square root of negative 4? Well, if I separate this into square root of negative 1 times 4, right? I can then separate this even further. I can say negative square root of negative 1 times the square root of 4. Square root of 4, I know, is 2. It's really plus or minus 2. However, the square root of negative 1 is the definition of the imaginary unit, right? So I know that the square root of negative 4 is plus or minus 2i. Okay, so that's kind of getting us started on this lesson. So the first few powers of I, right? Let's talk about this for a second. Let's go I to some various powers. Okay. So I to the first power, or just I, is equal to square root of negative 1, right? We just learned that on the previous slide. That is the definition of the imaginary unit. Okay? But let's think about I squared for a moment. What does that mean? That means I times I. So that means square root of negative 1 times the square root of negative 1. Okay? So you could also say that is square root of negative 1 squared. Well, that's just going to give me negative 1. Right? What's the square root of 4? Squared. That's going to put me right back at 4. Right? Square root of 4 is 2. 2 squared is 4. Right? So those two things undo each other. Right? Squaring a square root cancels each other out. Right? So the I squared is negative 1. Let's look at I to the third for a moment. That's going to be the same as square root of negative 1 times square root of negative 1 times square root of negative 1. Well, I already know that I squared, I just learned right here that I squared is negative 1 times I. Right? I to the third, I can rewrite that as I squared times I. I know that I squared is negative 1. And I know that I is square root of negative 1. So the I to the third is going to be the same as negative I, right? Here's my negative. Square root of negative 1 is I. Then I get to I to the fourth. Well, if I break that down into 2I squareds, that's going to give me negative 1 times negative 1, right? I got that up here. Well, negative 1 times negative 1 is just going to be 1. Okay? Let's back up one step. Okay? An important step. What is I to the 0 power? Well, we learned in probably 8th grade that anything to the 0 power is 1. Whether it's 7 to the 0 power or 7,000 to the 0 power or even that imaginary to the 0 power is going to be 1. So the main thing, I know I threw a lot at you right there, but the main thing I want you to understand are these first powers of I. I to the 0, I to the 1, I squared, I to the 3rd, and you really don't even need to know I to the 4th because this all starts to repeat, right? We see the repeat happening right here, right? I to the 0 and I to the 4th are the same thing. Okay, so this is equal to 1. This is equal to square root of negative 1. This is equal to negative 1. This is equal to negative I, right? And then I to the 4th is where it starts to repeat again. So these are the 4 terms that you need to know. I to the 0 is 1. I is the same as square root of negative 1. I squared is negative 1. I to the 3rd is negative I. Okay, and we are going to use that concept to simplify these complex numbers. So, I to the 31 power. We don't want to build that list over and over again. So what I am going to do is I am going to take this exponent, the 31, and I am going to divide it by 4. Okay? I am going to take 31, I'm going to divide it by 4. Right? Well, 7 times 4 is 28, and there are 3 left over. Okay? I need it in remainder form. That means I have 7 groupings of I to the 4th. One, 2, 3, 4, 5, 6, 7, and then I have an I to the 3rd. All of these are equal to 1s. 1 times 1 times 1 times 1 times 1 times 1. So that means that all I need to deal with is this I to the 3rd. And I know from my list that I to the 3rd is the same as negative I. So all I am really concerned about is this exponent, or this remainder. Right, let's look at another example. I have I to the 17th power. Okay, I am going to take this 17. I am going to divide it by 4. Okay, 4 times 4 is 16, with 1 left over. All I need to deal with is this. Okay, this is going to be the same as I to the 1st power, which is just I. Okay, or square root of negative 1. Where this comes in more useful is simplifying something like this. What is the square root of negative 32? So I am going to separate the negative 32. I'm going to factor it out into negative 1 times 32. Okay, I know that the square root of negative 1 I can do. The square root of 32 I need to work on. Square root of 32. Well, I know that the largest perfect square that is a factor of 32 is 16. Right? Square root of 16 is plus or minus 4. Square root 2 times that square root of negative 1 yet. Square root of negative 1 is I. right? So I combine those because it's multiplication. Square root of negative 28. Let's factor it out. Negative 1 times 4 times 7, right? 4 is a perfect square. That's why I used 4. What is the square root of 4? Plus or minus 2. What is the square root of the negative 1? It is I. And then square root of 7 is going to stay under because it is not a perfect square, nor does it have a factor. Multiplying imaginary numbers, we're going to go term by term. Negative 3 times 2 is negative 6. And then I times I is I squared. I know from my list at the beginning of the chapter that I squared can be replaced with negative 1. So I know that negative 6 times negative 1 is positive 6. For part B, a couple of ways you could attack this. I would personally say combine these under 1 square root. Right? I can combine them under 1 radical. So negative 12 times negative 2 is positive 24. I know that 24 is the same as 4 times 6. So plus or minus 2 is the square root of 4 times 6. If you worked these separately, you would get negative 1 times 12 times negative 1, square root of negative 1 times 2, and then you could work these out that way, right? The square roots of negative 1 would become I. I times I is negative 1. So solving quadratics with imaginary numbers, you could attempt to put this into Desmos, but what this is going to give you, just a quick kind of sketch of what this would look like. All right, there's your XY coordinates. It's going to look like this. So it does not actually, in the real world, cross the axis. Right? But what I can do to solve this with imaginary numbers is work to isolate y. Right? So I'm going to subtract away the 20. Right? So I'm going to get 5y squared equals negative 20. Then I'm going to divide away this 5. I'm going to get y squared equals negative 4. So then I'm going to square root both sides. Y equals square root of negative 4. I'm going to factor out the negative. Y equals square root of negative 1 times 4. I know the square root of negative 1 is I, and I know the square root of 4 is 2, so I get a solution of 2I, right? It's an imaginary solution. It does not exist if I graph it in the real world. Adding and subtracting with imaginary numbers is going to go just like any other adding and subtracting. If we think of this imaginary kind of like a variable, it's not a variable, it is a imaginary number, right? But I'm going to do a combining of like terms. So what is 3 plus 2, right? I have 3 plus 5i in parentheses plus 2 minus 4i in parentheses. Well, 3 times 2 is 3 plus 2 is 5, right? This is plus, right? So I'm going to go 3 plus 2 is 5, and then I'm going to go 5i minus 4i is just I, right? So my solution is 5 plus I. I cannot break it down any further than that. Number 4, we are going to subtract. 4 minus 3 is 1. Negative 6i minus a negative 7i would be a positive I. Anytime we would have multiplying with imaginary numbers, right, we would just use any other, the same strategies we would use with any other multiplication. So let's look ahead at number 9 on your assignment. Number 9 says 3i times negative 2i times 5i. Okay, well, I'm going to multiply these coefficients, right? 3 times negative 2 times 5 would be negative 30, and then I to the third, right? I know from my list that I to the third is the same as negative I. So I would have negative 30 times negative I, which is going to give me the negative times negative is positive 30i. Right, so that's kind of just a look ahead. You will have some on your assignment that would be FOIL. Right, so let's just peek here. This is number 14. No, 18, sorry. 18. 5 minus 2i times 4 minus I. Right, you're going to FOIL. First times first. 5 times 4 is 20. Outside, 5 times a negative I, negative 5i. Inside, negative 2i times 4, negative 8i. And then negative 2i times a negative I would be plus 2i squared. So 20, combining like terms here, minus 13i, and then I squared is negative 1, so minus 2, right? This is negative 1 times 2 is negative 2. So that would give me 18 minus 13i. I know this is not a lot of fun, but it does really make you think. So complete your 3.2 assignment and get it submitted, please.